Satellite multiple accessing arrangement. Satellite multiple accessing implies that more than one user has access to one or more transponders within a satellite bandwidth allocation. The three most commonly used multiple accessing arrangements are frequency division, multiple accessing, time division, multiple accessing, and code division, multiple accessing. Frequency division multiple accessing, or FDMA, is a method of multiple accessing where a given RF bandwidth is divided into smaller frequency bands called subdivisions. FDMA transmissions are separated in the frequency domain and must share the total available transponder bandwidth as well as total transponder power. A control mechanism is used to ensure that two or more earth stations do not transmit in the same subdivision at the same time. Efficiently, the control mechanism designates a receive station for each of the subdivision. Thus, with FDMA, transmission can occur from more than one station at the same time, but the transmitting station must share the allocated power and no two stations can utilize the same bandwidth. Time division multiple accessing (TDMA) is the predominant multiple accessing method used today. TDMA is a method of time division multiplexing digitally modulated carriers between participating earth stations within a satellite network using a common satellite transponder. With TDMA, each earth station transmits a short burst of information during a specific time slot within a TDMA frame. The burst must be synchronized so that each station's burst arrives at the satellite at a different time, thus avoiding a collision with another station carriers. TDMA transmissions are separated in the tone domain, and with TDMA, the entire transponder bandwidth and power are used for each transmission but for only a prescribed interval of time. Thus, with TDMA, transmission cannot occur from more than one station at the same time. However, the transmitting station can use all the allocated power and the entire bandwidth during its assigned time slot. Code division multiple accessing (TDMA) is based on the use of modulation technique known as spread spectrum. Users are separated both by frequency and time. Because there are no limitations on bandwidth, CDMA is sometimes referred to as spread spectrum multiple accessing, or SSMA. With CDMA, all earth stations transmit within the same frequency band and, for all practical purposes, have no limitations on when they may transmit on which carrier frequency. Thus, with CDMA, the entire satellite transponder's bandwidth is used by all stations on a continuous basis. Signal separation is accomplished with envelope encryption decryption techniques. In both FDMA and TDMA, only one subscriber at a time is assigned to a channel. No other conversion can access the channel until the subscriber call is finished or until that original call to be handed off to a different channel by the system. Voice data tends to be burst in nature, so much of the time no data is being sent over the channel. This efficiency tends to limit the capacity of the system. The above drawbacks are overcome in this third technique, in which the users are spread across both frequency and time in the same channel. This is a hybrid combination FDMA and TDMA. For example, frequency hopping may be employed to ensure during each successive time slot, the frequency bands assigned to the users are recorded in random manner. An important advantage of CDMA over FDMA and TDMA is that it can provide for secure communication. GSM architecture. The GSM network is divided into three major systems: the network switching subsystem, the base station subsystem, and the operation and support system. The basic GSM elements are shown below. Network switching subsystem. The NSS is responsible for performing call processing and subscriber-related functions. The switching system includes the following functional units. Home Location Register. It is a database used for storage and management of subscription. HLR stores permanent data about subscriber, including a subscriber service profile, location information, and activity status. When an individual buys a subscription from the PCS provider, he or she is registered in the HLR of the operator. Visitor Location Register or VLR. It is a database that contains temporary information about subscriber that is needed by the MSC in order to service visiting subscriber. VLR is always integrated with the MSC. When an MS roams into a new MSC area, the VLR connected to that MSC will request data about the mobile station from the HLR. Later, if the mobile station needs to make a call, VLR will be having all the information needed for call setup. Authentication Center or AUC. A unit called the AUC provides authentication and encryption parameters that verify the user's identity and ensure the confidentiality of each call. Equipment Identity Register. It is a database that contains information about the identity of mobile equipment that prevents call from stolen, unauthorized or defective mobile stations. Mobile Switching Center. The MSC performs the telephony switching functions of the system. It controls calls to and from other telephone and data systems. Base Station Subsystem or VSS. All radio-related functions are performed in the VSS, which is also known as Radio Subsystem. It provides and manages radio frequency transmission paths between mobile units and MSC. It consists of many base station controllers and base transceiver station. Base station controllers. The BSC provides all the control functions and physical links between the MSC and BTS. It is a high-capacity switch that provides functions such as handover, cell configuration, data, and control of radio frequency RF power levels in BTS. A number of BSC are served by an MSC. Base Transceiver Station. The VTS handles the radio interface to the mobile station. The VTS is the radio equipment, transceiver, and antennas needed to service each cell in the network. A group of VTS are controlled by an BSC. Operation and Support System. The Operations Maintenance Center is connected to all equipment in the switching system and to the BSC. Implementation of OMC is called Operation and Support System. The OSS is the functional entity from which the network operator monitors and controls the system. The purpose of OSS is to offer the customer cost-effective support for centralized, regional, and local operational and maintenance activities that are required for a GSM network. OSS provides a network overview and allow engineers to monitor, diagnose, and troubleshoot every aspect of the GSM network. CDMA traffic channels. CDMA traffic channel consists of a downlink base station of the mobile unit channel and an uplink channel. The downlink traffic channel consists up to 64 channels, including a broadcast channel used for control and traffic channels used to carry subscriber information. The forward link uses the same frequency spectrum as AMPS. Four types of logical channels are present: a pilot synchronization, 7 paging up to 63 traffic channels. All these channels share the same 1.25 MHz CDMA frequency assignment. The traffic channels are identified by a distinct user-specific long code sequence, and each access channel is identified by a distinct access channel long code sequence. The pilot channel is included in every cell with the purpose of providing a signal for the receiver to use to acquire timing and provide a phase reference for coherent demodulation. It is also used by mobile units to compare signal strengths between base stations to determine when a handoff should be initiated. The pilot contains no information, but it is the strongest signal on the forward link, containing at least 20% of the total power.